So we're going to continue on with quadratics and talking about some important pieces of them. And there's an important part of a quadratic that you do a lot with in math, and that's called the roots. And the roots are the points at which the parabola hits the x-axis. Okay, these are also called your zeros. So sometimes people will ask for zeros. Sometimes people will ask for solutions. And sometimes people will ask for x-intercepts. Okay, I've seen it asked all ways. I'm not the maker of math. If I was, I would be like, choose one thing. So in your homework, they're going to ask for roots, zeros, solutions, x-intercepts. They're going to use all 4 of those words. They all mean the same thing. They mean where it hits the x-axis. So if I draw something, this would be a parabola. This has 2 solutions, one here and one here. Okay, I could draw a parabola that hits once. So just right there, I'm going to put the dots in there so you can see those. So that has 1 solution. And then you can have a parabola that has no solutions because it doesn't hit the axis. Here's the axis, it never hits. So it's either above, or you could have one that's below that goes like this. Either of those are no solutions. Now, when you get into Algebra 2, you're going to get way more into the no solutions ones and finding out what they do for your graph. So we're going to kind of do this the long way, and you're going to be really mad at me in the end because you're going to be like, why didn't you just tell me that to begin with? But if I tell you the secret, then you're not going to understand where it comes from. So we're going to go back and do this kind of like the long way. And I'm going to make you really mad in a minute, in like a couple days, I guess. Okay. So I'm going to go and we're going to do this kind of what I call the long way. Okay. So we're going to do our axis of symmetry. So my A is 1. My B is 4 and my C is a -5. So I'm going to do a negative B over 2A. So my axis of symmetry is a -2. So I'm going to put that in the middle of the chart. And then I put a -2 into here, and I have a -2 squared is 4, plus 4 times a -2 is a -8, minus 5. So that is a -4 minus 5 is a -9. So I have a point at a -9. So -2, 1, 2, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the whole point of this is to find the solutions. So I'm not going to necessarily always have to fill in this whole table. I'm just looking for where they hit. Okay, and once they hit the axis, I'm done with the problem. So I'm not going to write them all out. I'm going to just do them one at a time. So if I go up and I go down, if I put a -1 in, and -1 squared is 1, plus 4 times a -1, -4 minus 5. It's a -3 minus 5, which is a -8. Okay, so that goes here and here. Okay, and so then I'm going to keep going. I'm going to go and put 0 and a -4 in. So I'm going to put the 0 in if that's okay. So I'd have 0 plus 0 minus 5. So that's a -5. So that's still not hitting the axis. 1, 2, 3, 4, 5. I'm looking for where it hits the x-axis. Once it hits the x-axis, I am done with the problem, because that's all I need from this. So then finally I'm going to put in, hopefully this does it, 1 and a -5. So I'm going to put in the 1. 1 squared is 1 plus 4 minus 5. That's 5 minus, oh, there it is, 0. Okay, so that would be at 1 and at 1, 2, 3, 4, 5. So when I graph this thing, my solutions hit at, and they like to use x equals, and then they use the squiggly parentheses to show that this is not a coordinate, but it is 2 separate points. One of them is at a -5 and one of them is at 1. And I don't care what order you put those in. Okay. All right. So let's take a look at number 2. So again, I'm looking for where it hits the x-axis. Once I find it, I'm done. Okay, so I'm going to do A equals 1, B equals a negative 2, C equals 1, and I'm going to do a negative B over 2A. So that's 1, and I'm going to put that in the middle. Then I'm going to plug it in here. 1 squared is 1, minus 1 times 2 is 2, plus 1. Wait a minute, that's 0. 1, 0. And that's the vertex. And that's the solution, and I know it goes up. So if you want, you could put in like you could put in 2 and 0, and I could put in 0 pretty quickly. 0 minus 0 plus 1. I have enough points right here to graph it. I'm done. I don't have to keep going. I know what my solution is. My solution is 1. That it just has one solution. It just hits the axis. So I didn't even fill in the rest of these because I found where it hits the axis. That's the whole point of what you're doing right now. Once you find where it hits the axis, you're done. Okay, so let's take a look at number 3. A is a negative 1, B is 2, C is a negative 3. So I'm doing a negative B over 2A, and so that's 1. So my middle one is 1. I'm going to put 1 in here. 1 squared is 1, and then I'm taking the negative of it. And so that's a negative, sorry, that's 1 minus 3, which is a negative 2. Okay, so I'm at 1, negative 2. So then I'm going to put in 2 and I'm going to put in 0. Okay, so I'm going to go ahead and put in 0. Wouldn't that be 0 plus 0 minus 3? So isn't that a negative 3? Now I want you to think about this for a second. I am looking for where it hits the x-axis, and I just found the next 2 points. They're going down. They're going away from the x-axis. So if I don't have to do these other ones. I already know the answer. The answer is no solution. They don't work. It never is going to hit that axis. So you could end up with things that never, ever, ever hit. Okay? So what I would like you to do right now is I would like you to pause the video, and I would like you to do, let's do 4, and let's do 4, and I'm trying to decide if we want to do that one. Yep, let's do 4 and let's do 6. Okay, 4 and 6. Pause the video and do 4 and 6. So A is 1, B is a negative 10, C is 16. So I'm going to do a negative B, 10, divided by 2A. So my axis of symmetry is at 5. Plug that back in there. 5 squared is 25 minus 50 plus 16. So that's a negative 25 plus 16, which ends up being a negative 9. So I have a point at 5. 1, 2, 3, 4, 5. Negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so then I'm going to go ahead and I'm going to put in 6 and 4. So I'm going to do 4 because that's smaller. 4 squared is 16 minus 40 plus 16. So 40 minus 16, that's a negative 24, plus 16 is a negative 8. So it is going up. So again, once I find where it hits this axis, I can be done with the problem. Okay, then I'm going to put in, so, oh, sorry, that better go back. That was a negative 8. So I'm going to keep going, and I'm going to do 7 and 3. I'm going to choose to put 3 in. 3 squared is 9 minus 30 plus 16. 9 minus 30 is a negative 21 plus 16. Ends up being a negative 5, so it's getting closer, but it still hasn't hit. So 1, 2, 3, 4, 5, and right there. And so then I'm going to go one more, and that's 8 and 2. So I'm going to put in the 2. I guess I'm going to have to put it up here. 2 squared is 4 minus 20 plus 16. 4 minus 20 is a negative 16. Oh, here it is, 0. So it hits at 2 and it hits at 8. So my parabola goes up like this. Okay, so my solutions are 2 and 8. And I don't care what order you put those in. Some teachers you have to go smallest to biggest, but it doesn't matter for me because you just need to tell me where it hits. So again, on 6, I'm looking for where it hits the axis, and once it hits it, I'm done. So when I do this one, my A is a negative 3, my B is 6, and my C is 0. So I'm doing a negative B over 2A. So my axis of symmetry is 1. When I put that in there, remember, you're doing 1 squared first, and then you're timesing it by a -3. And so that's a -3 plus 6, so that's 3. So I have a point at 1, 3. Okay, then I'm going to go ahead and I'm going to put in 2 or 0. I like to put in 0 because then that's basically 0 plus 0, which is 0. Oh, boom, got it. 0, 2. Okay, I just found where it hits. I don't have to fill out the rest of the table. Okay, so my roots on this one are at 0 because it hits on the origin, and 2. Okay. All right, so the discriminant is something you're going to use a lot. And again, some of these formulas, you're going to use them a lot, but you aren't really going to know where they come from until later, which is really weird. And so you kind of just have to trust me. I'm going to show you where this discriminant thing comes from. But this helps you know whether it's going to go up or down. Okay, and so I don't know. I'm going to put the discriminant here, but I'm going to show you another way. So this is used to find solutions. Okay, so I'm going to show you this, and then you can decide which way you want to do it. Okay, so the discriminant is b squared minus 4ac. Write that down. You're going to see it a million times between now and when you graduate from high school. You're going to see it a lot. But I just hate throwing it at you, so I'm going to show you. If you don't like to use this formula because you don't really know it yet, there are other ways. So if this answer is greater than 0, there's 2 solutions. If this answer is 0, then there's 1 solution. And if the answer is less than 0, then there's no solutions. Okay, so I'm going to show you using the formula. So A in this problem is 1, B is 5, and C is 4. So if I use the formula, I'm going to do b squared, 25, minus 4 times 1 times 4. And that is 25 minus 16, which is bigger than 0. That's all I need to know. It's bigger than 0. And so you have 2 solutions. Okay, the other way you can do this is what we've been doing. You can kind of make a sketch. You can do, I have a negative b over 2a, so negative 2.5. And then when you plug that in here, okay, so I'm trying to find the vertex, negative 2.5. And when I plug that in there, I'm going to take my calculator and I'm going to do, in parentheses, negative 2.5, parentheses squared, plus 5 times 2.5 plus 4. And the answer is, oh, I forgot the negative sign because I am stupid, times a negative 2.5. I forgot the negative. The answer is a negative 2.25, which means if I were to sketch a graph of this, I'm going back and I'm going down, and I know because this is positive, it opens up, so I know it hits twice. So you can sketch a graph, but you can see by that graph, sometimes they get really complicated, so it might be easier just to memorize that formula. So let's take a look at another one. So my A in this one is 1, my B is a negative 3, and my C is 10. So you're doing b squared, that's 9. It's positive because you're doing a negative 3 times a negative 3, minus 4 times 1 times 10. So this is 9 minus 40, which is a negative answer. That's all I need to know. So it has 0 solutions. So that means if I were to graph it, it would be going up, but it's going to be above the axis. Okay, so I would like you to try 9 and 10. Pause the video and try 9 and 10. All right, so like on number 8, that was a negative 31, the answer. But I'm just trying to find if it's positive, negative, or 0. And that tells me how many solutions there are. Later on, we're going to find out what that negative 31 means. But right now, I just need to know, is it positive, is it negative? That's what I need. So on this one, my A is 1, my B is 10, my C is 25. So I'm doing b squared, so that's 100. Minus 4 times 1 times 25. Well, 4 times 1 times 25, because you do multiplying first, is 100. 100 minus 100 is 0, which means that it has 1 solution. That means it's going to hit right on the axis. Okay, so if I do this one, my A is 2, my B is a negative 4, and my c is a negative 3. So b squared, negative 4 times a negative 4, that's 16, minus 4 times a times c. So 4 times 2, that's 8. Negative 8 times a negative 3 is a positive 24. So that means this answer is going to be positive. Yes, it's going to be a positive 40, which we just need to know, is it positive or negative? Okay, now I could have sketched my graph. I'm going to just come over and I'm going to do this one right here, number 9. I could have sketched my graph. I could have done a negative b over 2a and got a negative 5, and then plug the negative 5 back in there. Negative 5 squared is 25 minus 50, because 5 times negative 5 times 10 is a negative 50, plus 25. That's a negative 25 plus 20. That's 0. So that just told me the vertex is on the axis, right? If I sketch it, negative 5, 0, and this thing opens up, it hits once. So you could have sketched the graph, okay? You could have sketched the graph on number 10. So if you look at number 10, I'm just going to kind of come down here. On number 10, you could have done a negative b over 2a. So my vertex is 1, right? And then I'm going to put 1 in there. 1 squared is 1 times 2 is 2, minus 4 times 1, minus 3. So that right there is a negative 2 minus 3 is a negative 5. So if I sketch this, my vertex is at 1, negative 5, like we sketched before, and I open up, it hits twice. So you can find these by sketching them, or you can find them by doing the formula. I think on 11 and 12, you can kind of see why the formula comes in handy, because those numbers start getting really big, and to try to sketch the graph is going to be hard. Okay.